Good day. How are you doing today? So in this lesson, I'm going to show you how to do implicit differentiation. So some may be wondering, what are those implicit functions? So for example, if you're given y is equal to x cubed plus 2x squared plus 3x plus a 4. This is an explicit function. It is explicit because it is explicitly in terms of x. However, you can have the other functions such as x squared plus y cubed plus 4y squared is equal to 0. This function, it's not explicitly in terms of x only. You've got y variable, you've got x variable. So these are the functions which are called implicit functions. So to differentiate these functions, what you do, you just differentiate the x part. So this part, you've got this about 3 terms here. So for the first term, the derivative of that term will be 2x. And every time when you differentiate a variable y, you will say that will be 3y squared. Then you attach a dy dx to it. Then plus here the derivative of 4y squared, that will be 8y. And remember, a dy dx. So every time we differentiate a y, we will include a dy dx. Then that is equal to 0. Derivative of 0 is 0. Then you leave the terms that have got a dy dx. So you just want to make the dy dx the subject of the formula. So then you move everybody that doesn't have a dy dx. So you've got now 3y squared dy dx plus 8y dy dx is equal to a negative 2x. Then you just factor out your dy dx because you want to make it the subject. So then you just say 3y squared plus 8y bracket dy dx is equal to negative 2x. Then you just divide both sides by 3y squared plus 8y. Then that gives you dy dx is equal to negative 2x divided by 3y squared plus 8y. And that's how you do implicit differentiation. Okay, let's move on to other examples. So in example number 1, we are asked to find dy dx in terms of x and y when 3x squared plus 2y minus 4y squared is equal to 10. Remember, this is also an implicit function. We have got, it's not only explicitly in terms of x, we have got x, y, and another y variable. So remember, we differentiate here the first term, 6x, then plus the derivative of 2y, that will be 2. Remember, every time we differentiate a term that has got a y variable, we include dy dx. So it's a 2 dy dx minus, that will be 8, then y again, dy dx. And remember, the derivative of 10 is just a 0 because a derivative of a constant is a 0. Then we leave all the terms that have got dy dx this side because we just want to make dy dx the subject. So say 2 dy dx minus 8y dy dx is equal to negative 6x. Then we just say 2 minus 8y in a bracket dy dx is equal to negative 6x. Then we just divide both sides by 2 minus 8y to be left with dy dx, which is equal to negative 6x divided by 2 minus 8y. And there you go. You have got your first derivative. And that's how easy it is. Then in example number 2, we are asked to determine the dy dx in terms of x and y when 2x squared y minus 4y is equal to y cubed minus 7x. So bear in mind here we've got a product. So this is also an implicit function because it's not only explicitly in terms of y or in terms of x. And we have got a product here. So we need to use our product rule. So to do that, remember here we can let u be equal to x squared and our v be equal to, so we're just differentiating this term first. So our v be equal to y. So du dx will be equal to 2x and dv dy will be equal to 1. So remember, every time you differentiate a y, you put a dy dx. Right. So we will now need to use our product here, which is v du dx. So in this case, that will be a 2 multiplied by v du dx. That will be y. We don't put a dy dx for now for this because we didn't differentiate y. So now that is v du dx. Then multiply by 2x plus u dv dx, x squared. Then multiply by 1 dy dx. We just write dy dx. And then you're done with your product rule. Then you continue with these other terms. And that will be minus 4. Remember, we are differentiating where y is. So we include our dy dx. That is equal to 3y squared dy dx. Never leave your dy dx when you differentiate the variable y. Then minus 7. Now, then we just expand this bracket here. That will give us 4xy plus 2x squared dy dx minus 4 dy dx is equal to 3y squared dy dx minus 7. So we just want to leave all the terms that have got dy dx on the left-hand side so that we make dy dx the subject. So we will be left with 2x squared dy dx minus 4 dy dx minus 3y squared dy dx is equal to, here that will be a negative 7 minus 4xy. So we factor out our dy dx, then we divide that side. So then we'll be left with dy dx will just be equal to negative 7 minus 4xy, all divided by 2x squared minus 4 minus 3y squared. And that's how you differentiate this function. In the next example, we are asked to find dy dx in terms of x and y when x cubed plus 4y squared plus 2x minus 4y plus 4 is equal to 0. This is again an implicit function. It's not explicitly in terms of x. You have got a y variable and an x variable. So to do that, we just differentiate one term at a time. So that will be 3x squared. You don't need a dy dx when you differentiate the x variable. And when you derive the y variable, remember to put your dy dx. Never leave your dy dx when you differentiate y. Then plus, here that will be a 2, then minus 4 again, dy dx. It doesn't matter, we've got a y variable that is left after we derive, but we derived the first term that was a variable y. Then plus a 0 is equal to 0 because derivative of a constant is 0. Then we leave everything that has got a dy dx on the left-hand side because we want to make dy dx the subject. Then we have got 8y dy dx minus 4 dy dx is equal to negative 2 minus 3x squared. Then we just factor out dy dx, then 8y minus 4 in a bracket dy dx is equal to negative 2 negative 3x squared. Then finally, you just divide both sides by 8y minus 4. Then dy dx is equal to negative 2 minus 3x squared, all divided by 8y minus a 4. And that's how you derive this function. And lastly, in this example, you are asked to show that dy dx is equal to 2y squared minus 2x cubed over 3x squared y squared minus 4xy minus 3 when the function is x squared y cubed minus 2x y squared is equal to 3y. So remember, now we've got a product, so we use the product rule. So we do v du dx. So we do x squared multiply by the derivative of y, that is 3y, that will be 3y squared. Remember, a dy dx. So we differentiated y to begin with. Then plus, then we differentiate x. That will be 2x y cubed. There is no need for dy dx because now we have differentiated x only using the product rule. Minus 2 in a bracket, v du dx. Let's derive x first. Then that 2 will just be 1 and we'll be having y squared. Then plus, then let's differentiate y. That will be the 2y So that will just be 2y. So that's 2xy. Then dy dx. Remember that. We need a dy dx when we differentiate the y variable. And that's equal to 3 dy dx. Now, we just expand that bracket there. Then we get, in this one, that will be 3x squared, y squared, rearranging that, dy dx, plus 2x y cubed, then minus 2y squared, minus 4xy dy dx is equal to 3 dy dx. So we bring all the terms that have got a dy dx to the left-hand side so that we divide. We factor so that we make dy dx the subject. Then we have 3x squared y squared dy dx minus 4xy dy dx minus 3 dy dx is equal to, then we just post all the other terms that doesn't have a dy dx, and that will be, in this case, 2y squared minus 2xy cubed. Then we factor out our dy dx in this case. Then we are left with, in the bracket, 3x squared y squared minus 4xy minus a 3 is equal to 2y squared minus 2xy cubed. Then we just divide by this whole thing to be left, so that we are left with dy dx is equal to 2y squared minus 2xy cubed divided by 3x squared y squared minus 4xy minus 3. And that's exactly what we are asked to show. So we just write shown. So this is how you do implicit differentiation. Let me know in the comment section if you've got any points of clarification or questions. Hope to see you again in the next lesson.